So we're going to be solving some problems for higher order. The first one أول واحد اللي بنسويه هو هذا equation. زين. This is a fourth order equation. y4, y3, y2, y1 plus 4y. So the first step, again, you're going to be doing your auxiliary equation, which is lambda to the power of 4 minus 4 lambda to the power of 3 plus 5 lambda to the power of 2 minus 4 lambda to the power of 1, which is just lambda, plus 4 is equal to 0. All right? This is going to be your very first step. In the example, it is solved in a different way. But again, you can solve this the same way using your guessing or assumptions and all of that. And how do you do that? Again, you're going to be looking at الفور اللي هني. الفور اللي هني, what are its roots? 1, 2, or what are its factors? 1, 2, and minus 1 and minus 2. We're going to do our trial and error. Trial and error. First, we're going to try for lambda equal 1. We'll plug it into the equation, which is 1 to the power of 4 minus 4 lambda cubed, 1 cubed, plus 5 into 1 squared, minus 4 into 1, plus 4, which is equal to 0. All right? Put this into the calculator. We need to know if it actually is 0. So it's 1 minus 4 plus 5 minus 4 plus 4. We get 2, which is not equal to 0. So lambda 1 is not a root. Let's try for the next value. Let's try for 2. Okay? So lambda equal 2. معناته we're going to plug in 2 power 4 minus 4 into 2 power 3 plus 5 into 2 power 2 minus 4 into 2 plus 4 equal 0. All right? And we're going to check for that. So again, we're going to plug this into our calculator. So 2 to the power of 4 minus 4 times 2 to the power of 3 plus 5 into 2 to the power of 2 minus 4 into 2 to the power of 1, which is just 2, plus 4. This is actually a root. We get 0 equals 0. So this is a root. So one of our solutions is lambda minus 2. Again, when your root is 2, and out of the factor is going to be lambda minus 2. So this is our lambda 1. This is an actual value. All right. y2 not 4. You could actually also put up to 4. All right. But we only need to find one lambda value. So we're going in order. We're doing the factors of 4. The factors of 4 is 1 and 4, and then 2 and 2. Yani what two numbers you multiply, you get 4. Those are the factors. So we're going to try all of them from 1 all the way up to 4. That is the idea. And then, so -1, I never tested it. I usually go in order for the positive, and then I go in order for the negative values. It's up to you how you want to do your trial and error. Yani you can test the number until you basically get one of them, at least one of them, to be 0 equals 0. Because once you do that, then you can simplify, and then you can get out one of the powers and move on. So now that we know that lambda minus 2 is a factor, lambda 1 equal 2 is a factor, I should say. So we bring this down here, and we do what we did previously. You can either do long division, which will take a bit of time, or you can do the shortcut. So now our value is 2. All right. This is just the lambda that we found to be a factor. This is 1 minus 4, 5 minus 4, and 4. All right. So the steps, again, the first one, you're just going to take it all the way to the bottom. And to come 1, you're going to be multiplying 2 times 1. So this is multiplication, and the answer is going to be here. All right. So what's the answer? 2 times 1 is 2. Then we are going to be adding this with this. So minus 4 plus 2 gives us minus 2. Again, we're going to be doing the exact same thing here. So we're going to multiply 2 with minus 2. And the answer is going to be written here. So 2 times negative 2 gives us negative 4. And then we're going to add these two numbers. So 5 minus 4, or 5 plus minus 4, معناته 5 minus 4, which is 1. Again, the same thing. We're going to take this, multiply it with this, and the answer is going to be here. So this is equal to 2 times 1 is 2. Again, minus 4 plus 2 is going to give us negative 2. And the last thing, again, we're going to do it. We're going to multiply this here, and the answer is going to go here. So 2 times negative 2 is negative 4. And now the last point, if you add, they should give you 0, which it does. Since it gives you 0, معناته that this is actually a root, so we were correct from the very beginning. So now we can find what the bottom factors mean, or the coefficients. فأول coefficient, we started from lambda power 4. فمعناته here it's going to be lambda power 3. This is going to be lambda power 2. This is going to be lambda power 1, or just lambda, and this is going to be a number by itself. So if we want to write it down, this is going to be 1 times lambda 3 minus 2 times lambda 2 plus 1 times lambda minus 2. All right? And this is being multiplied with our factor that we took out earlier, which is lambda minus 2. Lambda minus 2. So we already have our first lambda. Lambda 1 is equal to negative 2. This is the first root that we have found through this. All right? And obviously, this is equal to 0. Now we are going to apply the same exact thing, the same exact method to this part of the equation. So we have lambda cubed minus 2 lambda squared plus lambda minus 2. We are looking at this part only, all right? Equal 0. This part, again, we will do the same method that we did earlier. We're going to be looking at the minus 2. We're going to be taking its factors out, and we're going to be doing trial and error. So we're going to be taking the factors of this, which is 1, 2, and minus 1, minus 2. Note, since 1 was already not a factor in the beginning, that means it's again not going to be a factor here. So you can just move on to the next value that you find. All right. So let us try 2 again. All right, because 2 was already a factor, but it might be a repeated factor, and we do not know until we find out here. So 1 we know for a fact is not a factor, so we're just going to remove it. We're not even going to try it, but let's try for 2. So again, this is trial and error. معناته we're going to have lambda equal to, let's see if that's the case. So 2 cubed minus 2 times lambda squared, which is 2 squared, plus 2 minus 2. And let's see if this is equal to 0. We need to check if it's equal to 0. 2 to the power of 3 minus 2 times 2 to the power of 2 plus 2 minus 2 gives us, what do you know? It gives us 0. Again, معناته this is also a root. Again, another time. So lambda 2 equal 2. So in other words, this is lambda minus 2 again. So if you notice, now we have a repeated real root, which is lambda equal to 2. We got it once here, and we got it another time here. So lambda minus 2 is a root, okay? So, or sorry, lambda 2 is a root. Now, again, we're just going to take our equation here and do the same thing, which is long division, or the shortcut of long division. We're going to apply it in the same exact way we did earlier. So the factors here are 1, minus 2, 1, minus 2. The value that we are looking at is 2. All right. Again, this 2, where did it come from? It's our lambda. Okay. This is the 2. First thing is we're going to take our 1, bring it down. So this is 1. Do the multiplication. And whatever the answer is going to go here. So 2 times 1 is 2. We're going to add up these two values. Minus 2 and 2 gives us 0. 2 times 0 is simply just 0. So this is going to be multiplied now with here. 2 times 0 is going to give us 0. All right. Now we're going to add these two numbers. 1 plus 0 is 1. Again, we're going to be multiplying this with the 1. So this will give us a value of 2 times 1, which is 2. Again, last part, we need to add them up, and it has to be equal to 0. Since it is equal to 0, we know our work is correct, and we know that this is a second root again. And now we're going to apply the same thing we did earlier. Since we have power 3 over here, we started with power 3. معناته this is going to be lambda power 2. This is going to be lambda power 1. And this is going to be no lambda. معناته we are going to have 1 lambda squared plus 0 lambda 1 plus 1 equal 0. And this is going to be multiplied by the first one that we have found at the very beginning, which is lambda minus 2. And the second one that we have found, which is lambda minus 2 again. Or you could say lambda minus 2 squared. But if you keep it this way, it's fine, as long as you understand what you are doing. All right? ليش في هالحالة ما عندنا 4 لامدا؟ لأنه we have already simplified the first lambda. إحنا هني طلعنا اللامدا, one of them, out of the 4. This is the whole idea. We are reducing it slowly until we get not a single lambda remaining. يعني ما عندنا any powers anymore. So the first one, when we took it out, we have a cube left because we start with 4 and then the next one is going to be 3. All right? Usually for lambda, this is for higher order. Yani when you have third order and higher, we usually use lambda to start solving. Now we have a simple quadratic. Let's simplify this equation a little bit. So this is lambda minus 2 into lambda minus 2 into lambda squared plus 0 times lambda is just 0. So plus 1 equal 0. So we have a quadratic here. This is an easy quadratic. You don't even need to ليش في اثنين؟ مثل ما قلت لكم عندنا الأحمر والبرتقالي. الأول ستيب الأحمر اللي هو lambda 1 when we had a fourth power. Once we found it as a root, now we are going to check again based on the factors of here, and 2 is one of the factors. So we are going to check again to see if it is duplicated or not, and in this case it is. So now this is another factor or another root اللي طلعناه because of this case of the lambda cubed minus 2 lambda squared plus lambda minus 2 equals 0. عشان كذي عندنا the first one from the beginning and the second one from the second one. And now we reduced it to a quadratic. So now we have this simple quadratic, which is lambda squared is equal to, or plus 1, is equal to 0. In other words, lambda squared is equal to negative 1. In other words, we're going to do the square root. So this is going to be lambda 3 and 4 is equal to, remember when you are doing square root, معناته we are having two possible values. We are going to have a positive and a negative value of the square root minus 1. When we have a negative, this means it's a complex value. So lambda 3, 4 is equal to the square root of negative 1, which is plus or minus I. All right. So what does this mean? This means that we have a complex root. So let's rewrite all of our lambdas again. So we have lambda 1, which was the red lambda. Lambda 1 is equal to minus 2, or sorry, plus 2. All right, lambda 1 was equal to plus 2. And lambda 2, again, lambda 1 was the one we got at the very beginning over here. We found that lambda 1 is equal to 2 because of the plugging in, and we got 0 equals 0. This is our first root. Lambda 2 is equal to 2. Again, from plugging in here, we found out that this is our second root, which is a repeated root. So we have lambda 2 is equal to 2. We have lambda 3, 4, which is equal to, I like to write it in this way, which is 0 plus or minus I. All right? ليش؟ لأن بعدين we will know that this is our alpha, and we know that here we have 1, which is our, شو اللون اللي ما استخدمته أخضر, 1 is our beta. All right? That is why I like to write it in this way. شلون أميز 1 2 3 و4؟ لو قصدك في اللامدا هني انزين it doesn't matter what you call 1 2 or 3 or 4, it doesn't matter. الفكرة هو انه you just differentiate between them, ان تعرفون which root is which. That's the only idea. يعني do not get too confused by the numbers. The idea is we started يوم طلعنا root خلصنا من number 1. So now we are looking for root number 2. يعني here now we are looking for our second root because we already have lambda 1. Once we have found lambda 2, now we are looking for lambda 3. All right, so here we were looking for lambda 3, but because this is a square, معناته when we do the square root, we are going to have two roots for a quadratic equation. So that's why it is 3 and 4. All right, because this was complex, I just kept it as lambda 3, 4. If it was real, I was going to find lambda 3 by itself and lambda 4 by itself. All right, now now we can write our general. ليش خلينا lambda تربيع؟ لأن lambda squared plus 1 from here, from this equation. We have lambda squared, lambda 1, and no lambda. We have 1 for lambda squared, and then we have 0 for lambda 1, and then we have 1 for the one without lambda. If you simplify this, you get lambda squared plus 1. Lambda squared plus 1, we want it to be equal to 0. The idea is every time we want to equate whatever's in the brackets to 0. الحين هذا is equal to 0. And we solve this equation for 0. We take the 1 to the other side, we get minus 1. And now we want to find lambda by itself, so we have to take the square root. Once you take the square root, you're going to have two lambdas, lambda 3 and lambda 4. You're going to have two values for the roots. You're going to have a positive and a negative value of whatever is under the square root. Because we have minus 1 in the square root, remember that the square root of minus 1 is equal to j or I. In this case, you guys are using I, so let me keep it as I. Okay? It is a complex number. But because it's under the square root, we are going to have plus and minus in the case of finding for lambda. Tamam? So it's going to be plus minus I. The reason it is plus and minus, by the way, just so you guys understand, I already explained this, but I'll explain it again over here. لأن, let's talk about a basic number. Let's talk about the square root of 4. It is equal to plus or minus 2. Why? لأن if you do 2 times 2, which is equal to 2 squared, that's going to give you 4. And if you do minus 2 times minus 2, that's going to be, the minus and minus are going to cancel, so you're going to have minus 2 squared, or just simply 2 squared. Then the minuses are going to cancel, which is 4 as well. That's why the positive and negative values stay. So if lambda squared, when finding the roots, it has two roots. Yes, every time you have squared, you're going to have two roots. شوفوا. Here, this equation has 4 roots. Why? Then we have power 4. So when we have power 4, this entire differential equation is going to be, or in this case, this algebraic equation is going to have 4 roots. If it was a third order, like in the case over here, this is going to have 3 total roots. So what are we doing? We are removing one root so we can make it simpler and then find the remaining roots. فبنروح تحت هني. Now we have only 2 roots remaining inside of this because it is power 2. So when we are simplifying this, we do the square root, we are going to find 2 roots of lambda. ليش عكست الإشارة وخليت 2 موجب؟ Remember that our root is equal to 2 in this case. معناته, if we want to factor it, if we wanted to put it in factoring form, we want it to be 0 at the end. Whatever is inside here should be equal to 0. So when lambda minus 2, يوم بنحط 2 inside, يستوي 2 minus 2, which is equal to 0. This is why we factor it this way. So when you take out the root, it's going to be the opposite sign in a factoring form. All right? بعد أسئلة اسألوا قبل ما I do the general equation because this is the most important thing. متى يكونون غير ومتى نفس الشيء complex أقصد. complex دائما يكونون يعني it's always going to be like this in this way. You're always going to have two complex numbers that are conjugates always, unless you have a complete different formula هني, which is another case completely, but I haven't seen such a case so far. بس في هالحالة I think I actually solved one of those cases last time. Alright, you can refer to the older video. إيه يعني الفكرة هني we want every part of this to be equal to 0 لأن إحنا our final answer is 0. Alright, this is case 3 where we have multiple when we have another complex number يعني when we have another complex set يعني for example if lambda 1 and 2 was complex then we are going to have two complex sets and we're going to use case 3 and case 4. In this case we don't have anything يعني it's just a normal case 3. Alright, انزين عشان نشوف بعد اوكي تمام خلينا نكمل. We'll solve more examples until you guys get the point. Don't worry. So this is lambda 1 is equal to 2, lambda 2 is equal to 2, and lambda 3, 4 is equal to plus and minus I. So now for our general solution, for the first two cases, what is the case we have here? We have repeated real roots. معناته we are going to have to apply C1 e to the power of lambda 1 x plus C2 e to the power of lambda, sorry, C2 times x, لأن it's a repeated root, e to the power of lambda 2 x. All right, this is for the first case, for the repeated lambda 1 and lambda 2 values. Plus, now let us look at our other case, which is just a complex case. It's just a basic complex case. So what is the complex case? It is going to be e to the power of alpha x cosine cosine, well, نسيت C1 and C2 again. So in this case, we have C1, we have C2. This is going to become C3 cosine of beta in this case, or actually we'll just keep it as beta for now, x plus C4 sine beta x. Again, C1 is for the first term, C2 is for the next term, whatever type it is. And then after that, you're going to have a new constant, you're going to name C3. And then after that, you're going to have a new constant, you're going to name C4. All right, it doesn't matter the numbering of them as long as they're just not the same. You go in order. الحين خلينا نعوض. ف y is equal to C1 e to the power, what is lambda 1? It is 2x plus C2x e to the power of lambda 2, which is 2x, plus e to the power of alpha, our alpha value here is 0x, times C3 cosine beta, which is just 1x, plus C4 sine beta, which is 1x. All right, so again, this 2 is lambda. This lambda 2 is this 2. This 0 came from alpha, and these two values are beta. The one here and the one here. Last step in just simplifying everything. The first one, because it is repeated, we can take common factors, so C1 plus C2x. زين, we're taking e to the power 2x العامل المشترك, فبيكون e to the power 2x outside here, plus e to the power of 0 basically means 1, so we can just remove it. So it's going to be plus C3 cosine of x plus C4 sine of x. What if we had C1, 2, C2, 1? In this case, what should we do? They will be repeated? No, they are not. If C2 is equal to C, do you mean C2 or lambda 1 and lambda 2? Are you talking about C2, C1 or lambda 1, lambda 2? Okay, if you're saying, yani the question was, what if lambda 2 was equal to 1? If it is equal to 1, you're not going to put the x here. This is just going to be C2e to the power. It's going to be a normal distinct root. These are going to be different roots than each other. So what you're going to be doing is, you're going to be putting C2e to the power of lambda 2x. يصير يكون في complex repeated, and I already solved the complex repeated last time. You can refer to that video. I will solve a few more questions. Maybe one of them is going to be complex repeated. I don't know, and I haven't seen the solution بصراحة. But let us solve another question so you guys get a better idea of how to do it again. All right. Let me see if there is one with a complex repeated. For examples. غير هذا already سويته. This is all distinct. I can't see any that has complex repeated so far. So let me just solve the worksheet. Let me solve an example. So the question from the worksheet, let us do let's see. حليت المثال الثالث في السلايدات in the previous video. You can refer to it. Wait, actually, let me check. No, I did not. Do you want me to solve? It's very simple. This one's much easier than what I just solved. Yeah, this one's much more straightforward. Let me see. Yeah, this one's super easy. يلا ما عليه. Let's solve it. يلا عن خاطرك. So this equation is y to the power of 4, or I should say not y to the power of 4, y4 prime minus y3 prime plus 2y prime equal 0. Keep in mind here we are missing the second prime, so we don't have y double prime available. All right. So what does this mean when we are doing our auxiliary equation? We have r power 4, or actually lambda power 4, minus lambda power 3 plus 2 lambda, okay, because this is power 1, equal 0. All right. Now, what can we do? Since lambda is available in all of them, the first step we can do is take lambda out as a common factor. So we will be left with lambda cubed minus lambda squared plus 2 equal 0. So see, the idea here is we're trying to reduce this 4 to 3 and then to 2 eventually, and then to roots all over the place to get our roots. Okay, for lambda 4 became lambda 3, lambda 3 became lambda 2, and 2 lambda became 2 because we took one lambda outside because we can take it common from all of these. So our very first root is lambda 1 equal 0. ليش؟ لأن عندنا lambda outside here. If lambda was 0 times whatever is inside here, then this will be equal to 0. Then this entire thing is going to become 0. This is why lambda equals 0, or lambda 1 is equal to 0. It is a root. All right. So this is the first step. Now let us look at the middle part, which is lambda cubed minus lambda squared plus 2. All right. A better way to write this so you guys don't get confused, either you guys are getting too confused, you can write it as plus 0 lambda. All right. 0 times lambda is simply 0. And now you can do this using the trial and error method. So what are the roots? Remember, we want this to be equal to 0. And then, so what are our roots? عندنا هني our factors 1, 2, minus 1, minus 2. All right. Trial and error. Let's try 1. So for lambda equal 1, plug it into this equation. It's going to be 1 minus 1, and 1 cubed minus 1 squared plus 0 plus 2. And we can see from here that this is not equal to 0 because 1 minus 1 is equal to 0. So we're going to get 2 equal 0, which is not the case. So lambda 1 is not a root. Let's try with lambda equal minus 1. So we're going to have negative 1 cubed minus 1 squared plus 0 plus 2 equal 0. This is going to be minus 1 cubed is just minus 1. minus 1, that's minus 2 plus 2, that's 0. So 0 equals 0, and this is a root. So our second root, lambda 2 is equal to negative 1. You can mention this here. Lambda 2 is equal to negative 1. In other words, we can factor this out as lambda minus 1 becomes plus 1. All right? لأن if we plug in minus 1 into this, this will become 0. That is what is meant by factoring this out. تمام? So, let us move on now and find what will be remaining from this part, which is our lambda cubed minus lambda squared plus 0 lambda plus 2. Then I added the plus 0 lambda so I can avoid any confusions. We have, what is our root? Minus 1. So we're going to put minus 1. Let's put our coefficients. Minus 1, 0. You have to put your coefficient for lambda so you don't get confused. Even if it's all equal 0, you have to put its coefficient. That's why you add it to your equation. Take the first one down. I'm going to do this super quickly because you guys should already know how to do this. So 1 minus 1 times 1 is minus 1. Add these two, you get 0. Minus 1 times 0 is, wait a second. No, plus, you get negative 2, sorry. Minus 1 and minus 1, you get negative 2. Minus 1 times minus 2 is going to be positive 2. So 2 minus 1 times 2 is negative 2 and 0. All right? What does this mean? This means we started from lambda cubed, معناتها بيبقى لنا lambda squared, lambda, and this is empty or open or يعني without a lambda. So if we write this in equation form, in brackets, يعني it's 1 lambda squared minus 2 lambda plus 2. And what do we have outside? We have the root that we have just determined, which is lambda plus 1, or the factored root, اللي هو lambda plus 1. And from the very beginning, we have also found that lambda is outside, اللي هو من البداية اللي هني. This lambda is outside. Okay? So we have lambda into lambda plus 1 equal 0. تمام? If this is way too confusing for you guys, you can keep it on the side and not look at it. It's fine. All right. But this is the proper way of writing it. The idea is you want to always simplify the things that you haven't found the roots of. All right. Yes, the last root here must be 0, so we know that this is actually a root that we have found. If this was not 0, you might have made a mistake either here, or you might have made a mistake when substituting here. تمام؟ ايه تسوون هالطريقة يعني you put your 0 for any lambdas that are missing. يعني in our question we did not have y double prime. That's why we can put this equation as, from the beginning so you guys don't get confused, write this as minus y triple prime plus 0 y double prime plus 2y prime equals 0. Do this from the very beginning. When you do this from the very beginning, and keep the 0 y double prime. If you do this from the very beginning, you're not going to get confused while you are solving. Okay, so now let us look at the quadratic. Lambda squared minus 2 lambda plus 2. How do we simplify this? You guys can do mod 5-3, or you can do a quadratic equation, whichever is easier. I'm just gonna do, I mean, not whichever is easier, but you should do the quadratic equation, but you can always check using mod 5-3. I'm gonna just do mod 5-3 really quickly. 1 minus 2 and 2 is gonna give me 1 plus I and 1 minus I. In other words, lambda 3 and 4. Let me change the color. So lambda 3, 4 is going to be equal to 1 plus or minus I. All right. I used mod 5-3, but again, you guys should know how to use it using the quadratic formula. So now we have all our lambda values, and then a lambda 1, which is equal to 0, and then a lambda 2, which is equal to minus 1, and we have lambda 3 and 4, which is equal to 1 plus or minus I. Okay? So the general equation now is going to be very simply y is equal to, so here we have distinct roots. So we have distinct roots here. Distinct real roots. Okay, this is going to be c1 e to the power of lambda 1 x plus c2 e to the power of lambda 2 x, your basic general formula. Here we have complex, one complex number, which is just going to be plus e to the power of alpha x into c3 cosine of beta x plus c4 sine of beta x, where our beta and alpha are. This is our beta, which is 1 over here. This is beta, and alpha is 1. Plug all of this back into the equation. Y is equal to c1 e to the power of negative 1. Oh, sorry, lambda 1 is 0. So 0 x plus c2 e to the power of negative 1 x plus e to the power of alpha, which is 1 x, c3 cosine beta, which is 1 x, plus c4 sine beta, which is 1 times x. And this is your final solution. So, or your general solution, I should say. So here it's going to be c1 e to the power of 0 is 1, I mean, plus c2 e to the power of minus x plus e to the power of x into c3 cosine x plus c4 sine x. And this is your general general solution. Okay. عادي بدال lambda اكتب r. Yes, you can do that. You don't need to write lambda 1, lambda 2, lambda 3, lambda 4. You can put m, you can put d, you can put l, you can put whatever letter you want. Lambda is usually used because it's just the more I don't want to explain why lambda is used, but it is used for a lot of reasons because it's used in linear algebra as well. But it is just the general term that they use for higher order equations. All right. So in second higher order, we always differentiate the equation for a particular solution, or does it depending? It depends on the question. I will give you an example very quickly. And then, let's say you are given you found your general equation and all of that. Okay. So his question was, do we always differentiate? If you are given at x equals 0, y is equal to 5, and at x equals 0, dy by dx is equal to 3. Because you have dy by dx, that means you're going to have to differentiate. معناته you're going to have to differentiate your general differentiate. المهم, you get the point. You have to differentiate. But what if they did not give it to you as this? What if they said at x equals 0, y is equal to 5, and at x equals 3, y is equal to 10? You don't have to differentiate. You can just use your general solution to find these two values. So the first time you're going to plug in for y, for example, let's say c1 e power 3x plus c2 e power 2x, for example. And then all you're going to do is you're going to be plugging your first values here for y and for x, and you're going to get your equation 1 for c1 and c2. Then you're going to be doing the exact same thing again here. For equation 2, you're going to be plugging them back in, and you're going to get a second equation, c1 and c2, and you'll apply your simultaneous equation. So it depends on your initial values that are given. All right. So when you look at your initial values, if there's a differentiation in your initial value, معناته you have to differentiate. Now, I know you guys have a lot of questions, بس بصراحة the questions will never finish. So I want to do at least one particular solution for a higher order. And the only one I have seen is this question, which is y triple plus y double plus y single plus y equal 0. They gave you the most easiest basic equation to solve, by the way. And then, but it's good because we're not trying to look at the concepts here. I'm not trying to test this now. I want to show you how to get a particular solution. So, أول شيء we're going to solve for the general solution. So this is going to be lambda power 3 plus lambda power 2 plus lambda power 1 plus 1 equal 0. First step, you're going to be looking at your 1. What are the factors? You have 1 and minus 1. And then, obviously, I'll tell you for now, if you put 1 in here, this answer is going to be 4 because 1 plus 1 plus 1 plus 1 is 4. But if you put minus 1, it's going to become minus 1 plus 1 minus 1 plus 1. So it's going to be 0. So I can tell you from now that lambda equal minus 1 is a root. Okay, so that's our first root. So in other words, we have lambda plus 1 that we can take out. Now let us do our simplification, which is going to be very simple, by the way. So we have 1, 1, 1, 1. And what is our root? Minus 1. So first one is 1. Minus 1 times 1 is minus 1. We add them, 0. Minus 1 times 0 is 0. Add them, 1. Minus 1 times 1 is 1. 1 minus 1. Sorry, it's negative 1. 1 plus minus 1 is 0. Since we got 0, we know that negative 1 is a root. All right? Meaning that our equation, remember this was lambda 3, lambda 2, lambda 1, and that's it. All right? معناته هني بيكون عندنا lambda 2, lambda, and that's it. And then there's just this value by itself. So in other words, we have 1 lambda 2, or lambda squared, plus 0 lambda, plus 1 equal 0. All right? And of course, the lambda that we have found earlier, which is lambda plus 1. Simplifying this, we're going to get lambda plus 1 into lambda squared plus 1 equal 0. Similar to before, we want now the square to be 0, so it's going to be lambda is equal to plus or minus. Let me go step by step so you guys don't get confused. Lambda squared is plus 1 equal 0. Right, so now we want to find lambda squared, which is equal to negative 1. Lambda is going to be equal to the square root plus or minus of negative 1. Therefore, lambda, I should say lambda 2, 3. Oh, it's a third order. Okay. So lambda 2, 3 is equal to plus or minus I. All right, which I have already done. We had a similar example here. We can find now our general solution because we have already found lambda 1 was equal to negative 1. معناته we have distinct and the complex, so, or we have a real root and the complex root. Remember that this is simply just 0 plus I, it's the same thing. Okay, so you don't get confused. You have a real part, it's just 0. Y is equal to, I'll just plug in directly, C1e to the power of negative 1x plus e to the power of alpha, which is 0x. معناته this is just going to go away because it's 1. C2 cosine beta, which is 1x, plus C3 sine x. Okay? Again, it's a very general form, very easy. We've done it a million times. That's why I just did it instantly. Tamam? Now, how are we going to solve for this? Is our general solution. We are done with the question. من ناحية الجنرال solution, we have found it. This is our general solution. All right? But we were given initial values. We were given that the first initial value we were given was y of 0 is equal to 1. The second one was y double prime, or y prime, sorry, of 0 is equal to 1. And we were given that y double prime of 0 is equal to 4. Remember, all this means is that when x equals 0. Then this is what it means. All right, so if you notice here, for the first one, it's easy. For the first one, it's just y of 0. معناته we can just use our general directly and plug it in. So let's look at this general equation that we have. All right. So for the first one, we have x equals 0, y equal 1. معناتها 1 is equal to c1 e power 0 plus c2 cosine of 0 plus c3 sine of 0. All right. This is our first equation. If you notice here, e to the power of 0 معناتها 1 is equal to c1 plus cosine is 1, so c2. c3 sine 0 is 0, so we just have 1 is equal to c1 plus c2. And this is our first equation. So we have our first equation. In this case now, because this is a third order system, we're going to have 3 unknowns. So we need 3 equations to solve. That's why we were given 3 initial value problems. The second one, we're given y prime. معناتها we have to differentiate this general solution. It's very easy to differentiate as well because the e got cancelled. So y prime is equal to negative c1e minus x, because remember there's a negative sign here, so you're going to have to multiply it outside as well, plus, or minus, I should say, minus c2 sine x plus c3 cosine x. The reason it's minus now is because c2 cosine, when you differentiate it, you get minus sine, and then just sine becomes cosine. Now we have it. We have our differentiation. So what do? Again, we're going to look at the values they gave us. So at when x equals 0, y is equal to 1. So when x equals 0, y is equal, or y prime is equal to 1. Let's substitute these values. 1 is equal to minus c1 e to the power of minus 0, which is just 0, minus c2 sine of 0, plus c3 cosine of 0. Again, we start simplifying. 1 is equal to e to the power of 0 is 1, so it's negative c1. Sine of 0 becomes 0. Cosine of 0 becomes 1, so this is plus c3. So this is our second equation that we have. This was our first equation. This is our second equation. We have 3 unknowns, so we need to form a third equation now. What do we need to find? Y double prime. What does that mean? We are going to take our integration here, or differentiation here that we did, and we will differentiate for a second time. This is what is meant by y double prime. معناتها we are going to do the differentiation again. So minus c1e minus x becomes again plus c1e minus x, because minus times minus becomes plus. Minus c2 sine x becomes minus c2 cosine x, and plus c3 cosine becomes minus c3 sine x. And this is our second differentiation. Now we can plug in the values. So for 3, when x equals 0, y double prime was equal to 4. معناتها 4 is equal to c1 e to the power of 0, or minus 0 or whatever, minus c2 cosine of 0, minus c3 sine of 0. All right. Again, we simplify. 4 is equal to c1 e to the power of 0 is 1, so it's c1, minus c2 cosine 0 is minus c2, and then sine of 0 is 0. And this is our third and final equation. So now if we look at all of our equations, we have this equation, equation 1. Oh, where's equation 2 first? Equation 2. And we have our equation 3 over here. So we have 3 equations and 3 unknowns. Don't get too confused. You can either use substitution or something like that. But if you notice, for equations 1 and 3, they only have C1 and C2 in them. They do not have C3 in them. So you can solve for C1 and C2 directly using these 2 equations. And then whatever value you find for C1, you plug into equation 2 and you will find C3. So for equation 1, I'm just going to rearrange it so that I have C1 is equal to 1 minus C2. All right, all I did was move the C2 to the other side. And now I am going to plug into equation 3, which is 4 is equal to C1, which is 1 minus C2. All right, again, we got this from equation 1. Minus C2. معناتها 4 is equal to 1 minus C2, and minus C2 becomes minus 2C2. And let me take the 1 from here and put it here from now. So it becomes 3 is equal to negative 2C2. معناتها C2 is equal to negative 3 over 2. And we have found our first value for C. All right? So this is the first value for C that we have found, which is C2. Okay? Now that we have found C2, we can plug in C2 back into equation 1 over here. So from equation 1, C1 is equal to 1 minus C2, which is negative 3 over 2. معناتها our C1 value now is equal to 1 plus 3 over 2, which is 5 over 2. All right? And now we have found our second equation, or our second constant, which is C1. Now, after doing all of that, we can look at equation 3 or equation 2, which is equal to 1 is equal to negative C1, where C1 is 5 over 2 plus C3. معناتها if we solve for C3, C3 is equal to 1 plus 5 over 2. C3 is 7 over 2. And this is the final constant that we have. After solving for all these constants now, نروح نجيب original general equation that we found, which is here, and we just plug in the values for C1, C2, and C3 as we have found them. So this is our equation. C1 is 5 over 2. C2 is negative 3 over 2. And C3 is 7 over 2. All right? يعني من ناحية the particular solution, it is the exact same way of solving when it came to second order, even when it came to second order, yeah. But all you have to do is make sure you have, يعني, I don't think they're going to give you 4 equations and 4 unknowns. In equation 3, why you put C2 twice? هني, so we can solve for C2. We got C2 from equation 1 عشان we only have one unknown, one variable, which is C2, and solve and find the value for C2. ومن نحصل الفاليو مال C2 نقدر بعدين we can نعوض يعني, we can substitute it back here to find our C1, which is what we did. That's why. Again, simultaneous equations, this is very basic. You guys should be very well rehearsed in this. Okay? Any questions about this so far? Very straightforward, right? Yallah. The last question I am going to do today is going to be this question, because most of you have been requesting it. اللي هو y 5 plus 2y triple prime plus y prime equal 0. If we find our characteristic or auxiliary equation here, this is going to be lambda to the power of 5 plus 2 lambda to the power of 3 plus lambda equal 0. The first thing you're going to do, you're going to notice that we have lambda everywhere, so you're going to take it as a common. Lambda into lambda power 4 plus 2 lambda squared plus 1 equal 0. We have found our very first root, which is lambda equal 0. So lambda 1 equal 0. All right. Since we have this order 5, we know we need to find 5 total roots as our answer. So this is lambda 1. We know we need to reach all the way to lambda 5. All right. And if you notice, every time we find the root, the power of what we need to find decreases slowly. Now, this form of the equation you can do the trial and error method, but it's not going to work because, or you cannot do the trial and error method because it's not going to work. Why? Because you have, let me see actually, is it going to work? No, my one. No, it won't work. Why? Because you're missing the lambda cubed part. However, this is a quadratic equation. How is this a quadratic equation? احنا هني عندنا lambda squared plus 2 lambda جدي plus 1. An easier way to understand this, all I did was, يعني, this is power 4, right? Which is power 2 times 2. And this is power 2, which is power 2 times 1. All right? As if this is power 1, يعني. What I usually say is I write let u equal lambda squared to simplify how this process looks like. لأن أعرف يوم تشوفون وايد squares يلخبط. So this is going to become u squared plus 2u plus 1 equal 0. Right? U squared plus 2u plus 1 equal 0. Now this is a basic quadratic, so you know you can find your roots using this. Using mod 5.3, all right, you're going to get u1 and 2 are going to be equal to, so 1, 2, and 1, you're going to get, amazing. You're going to get negative 1. معناته you are getting a repeated singular root. In other words, you can say that u1 is equal to minus 1 and u2 is equal to minus 1. However, we are not talking about u. We need to solve in terms of lambda. Lambda is the actual roots of the equation. U is just something for me to simplify it for myself. So we need to plug in lambda now back for u1 and u2. فبيكون عندنا lambda 1 lambda squared is equal to negative 1. This is lambda, let's call it 2, all right, because we have already found lambda 1. So let's call this lambda 2. And because it's squared, we know we're going to have 2 and 3 here. And here, again, we're going to put our lambda squared. And this is going to be 4 equal negative 1. All right. Then we have a squared here. We know we're going to have lambda 2 and lambda 4. So just instead of confusing yourselves, just keep them as lambda and lambda squared for now. Now, when you are doing the square root here, square root of minus 1, we are going to have 2 and 3 because we're going to have plus and minus. And in this case over here, we are going to have 3, 4, and 5, which is equal to plus and minus square root of minus 1. So we know that lambda 2 and 3 is equal to plus and minus I. And lambda 4 and 5 is also equal to plus and minus I. All right? Again, احنا حصلناه in terms of u. يوم حصلناه in terms of u, we know that this is a quadratic. فمعناته الu عندنا two values of u, but they are a repeated root. They're both equal to negative 1. So when we're substituting for lambda squared, we're going to have two of lambda squareds. One for minus 1 and another one for another minus 1. But then when we do the square root, we're going to have this split into two pieces because we have square root, right? The squared becomes two unique or two roots underneath it. It will become a plus and a minus. And the same thing here. So here it's going to be 2 and 3, and here it's going to be 4 and 5. And as we have seen before, this is going to be our roots, which is 0 plus I plus minus I and 0 plus minus I. This is, if you notice, not in green, this is repeated complex roots. زين عندنا the same exact complex number and it is repeated. All right, and we have our lambda 1, which is just equal to 0, which is just a real case. Okay. Yes, this is case 4. Exactly. This is case 4, where we have a repeated root. So now when we want to write our general equation, y is equal to, for lambda 1, it's just the basic form, which is c1 e to the power of lambda 1 x. Now here, plus e alpha x into c2 cosine of beta x plus c3 sine of beta x. So far, it's good. Then we have a complex number, so we know this is going to be the general form. However, it is a repeated complex root, meaning now we are going to be writing the exact same thing. Then, let me just make this a bit smaller. Okay, so we're going to be writing the exact same thing over here, with the only difference being instead of just having e alpha x, we are going to multiply an extra x as well, because it is a repeated root. When it's a repeated root, whether it's complex or real, you're always multiplying the next part with x. Okay? So in this case, we have multiplied it with x, and now we can just plug in our values for each. So lambda here is 0, so c1 e0 x, plus alpha is 0, so e0 x, c2 cosine, beta is 1, so I'm just going to write it as x, plus c3 sine x, plus x e power 0 x, which is our alpha, c2 cosine x, or this isn't c2 and c3, sorry, this is going to become c4 and c5. لأنه وصلنا ل c3, so this is going to be the next constant, which is c4, and this is going to be the next constant, which is c5. All right? So c4 cosine beta x was, which is just 1, yani cosine x, plus c5 sine x. Last step of simplification, e power 0 is 1, so we have c1, plus e power 0 is 1, so we have c2 cosine x plus c3 sine x, and we have here again e0, so e power 0 يعني 1, so plus x c4 cosine x plus x c5 sine x. All I did was that x داخل, distributed it. The reason I did that is now you can see that you can rewrite this because we have cosine x here and here. We can take that as a common. So we're going to have c2 plus c4 x cosine x plus c3, which is our c3 over here with sine x as a common, plus c5x sine of x. This is just an extra step. I don't expect you guys or expect them to require you to do this step, but it just makes the equation a bit more neat. And that's pretty much it for higher order differential equations.